Alright, this is a homework problem from the P6 homework set. So what we're being told to do is add these fractions. So what we need to do is to get an LCD, just like we would do if our problem was something like 3/10 plus 5/14, something like that. What's the LCD? Well, one way you can get the LCD, now you can probably just look through it and think through it what the LCD is here, but one way you get the LCD even when it's numbers is you come up with what we call the prime factors of these. So the prime factors of 10 are 2 and 5, and the prime factors of 14 are 2 and 7. So they have a factor in common of 7. Then the other factors are not common. So what do we end up doing? The LCD ends up being the common factor that they both have in common, the 2, and then the other two things that are not common, so 5 and 7. And we would make the LCD from that, okay, 2, 5, and 7, all right, which is 70. But you know, how did I go from here, this fraction, to this new thing that's going to be equal to what it was before? It's just going to look different. Well, I had a 2 times 5. Now I have 2 times 5 times 7. So that means I multiplied by 7. So I need to multiply the 3 by 7. Whatever is different from the old denominator to the new denominator, I need to do that to the numerator, because effectively what I've basically done is just multiply by 1. 7 divided by 7 is 1. And so I haven't changed its value. I've just changed basically what it looks like. So that's how we're going to handle it when it's numbers. All right. The other one I had 2 times 7, so there's a 2 and a 7. 5 is what's different, so I multiply the 5 times 5. And that's how I would proceed through this problem. Okay, so the parallels between what we would do if it was numbers to what we would do with expressions like this is the same. The first thing I'm going to do is factor those denominators. 5 over, there's a common 6 right here, so I can pull the 6 out, and I'm left with x plus 2. All right, and then here I can pull a 5 out, and I'm left with, again, x plus 2. So in this case, x plus 2 is the common factor. Just like in the last example, 2 was the common factor. This time x plus 2 is the common factor. So that means my LCD is going to be 6, 5, the two things that are different, but then the x plus 2 just a single time. All right, and then I'm going to add, and the other fraction is going to have the same thing, 6, 5, and x plus 2. And then the 5 and the 4 were there to begin with, so I'm going to go ahead and put them in place. And then you ask yourself, all right, so what is different from what we had before to what we have now? Well, there's the 6, there's the x plus 2, so the 5 is different. That's the thing that wasn't there to begin with. So that means I need to multiply the old 5 that was there, right, by this new 5 on the bottom. And again, 5, the new things, the stuff in blue here, 5 divided by 5 is 1. So it's effectively like we didn't change it because we multiplied by 1. All right, and then the old right fraction, we had a 5 and an x plus 2. There's 5, there's x plus 2. So what's the new thing here? It's the 6. So that's what I need to multiply by to keep it equal to what it was before. Remember, we're saying these things are equal. For it to be equal, we can't change it. Its value, that is. So if we multiply on the bottom to get a common denominator, we have to multiply by that same number on the top to keep it equal. All right, and now just kind of simplify. 5 times 5 is 25. On the bottom, I get 6 times 5 is 30 times x plus 2. All right, and then the other one, 6 times 4 is 24. And then 6 times 5 is 30x plus 2. And then once you have common denominators, remember, if the denominators are common, that's going to be the denominator, and then you just add your numerators. So 25 plus 24 is 49. So that's what I would write there in that box. 49 over 30x plus 2. And it's fine if you distribute that through 30x plus 60 if you wanted to. Right? You can also just leave it 30 times x plus 2. When it says simplify here, it would mean, like, for instance, if this had been 50 instead of 49, you could reduce the 50 and the 30 down to 5 over 3. But you can't reduce 49 and 30. It just won't reduce. So it's fine to leave it factored. When it says simplify, it doesn't necessarily mean to distribute that 30 through. All right, and then what can x not be? So that's going to go in that box. And then let's do blue for the other box. What can x not be? Well, in the original fractions and in this sum, if x were -2, we would have 0 in the denominator. You see that? -2 plus 2 is 0, times 6 is 0. So 5 over 0, 4 over 0. You can't divide by 0. So x cannot be -2. All right, so that's what would go in that second box right there.